I hope this will be some kind of a meaningful conversation forward. Today, why I'm talking about appropriate technologies is for a particular reason. I told you about the calamity that the world is going to face in the coming days. Sustainability is very badly compromised in everything, and housing sector is no exception. In fact, the dilutions and things, undesirable things happening in the housing sector is a key factor to this thing. So, I mean, what I'm trying to tell you is that there is no other way out, my dear friends. Appropriate is the only way out. Only appropriate promotion of appropriate technologies, mainstreaming these appropriate technologies is the only way out when you talk about sustainable buildings. Having said that, I will slowly move on to the presentation, which will actually help me to get a much better, structurally detail it well and kindly do that. Yeah. Can you see that? Hello?
Yes, sir.
Yes, sir.
You can see that, no?
Yes, yes.
Appropriate technologies and appropriate material. Why this is needed? Go back. Why this is needed? One of the things that actually go back, the housing situation of India actually demands the usage of appropriate materials and technologies. I'll just tell you very, very briefly how this is going to affect. The housing situation in India is much beyond your comprehension, much beyond your, I mean, it is gone beyond our dreams, my dear friends. There are 70 million families, which means if you actually talk about a household of 5 people, we are talking about 350 million families. It's around 1/4 of the total population of India. 1/4 of the population of India means 1 in every 4. They don't have appropriate houses. They don't have proper houses. When I say proper houses, it talks a lot of the proper kitchen, it talks about proper toilet and things like that. There are many millions in this country who doesn't have access to proper housing. Now, how is it linked to appropriateness? My dear friends, we don't have the money to build for these people. India doesn't have the money, power to house these people. For building a house, you need money. That money is not there. When I say 70 million, even if you are talking about, say, 5 lakh, 500,000, this thing, what is the kind of money that it goes beyond your comprehension, it goes beyond your calculation. What I want to tell you is that housing situation in India is very, very grave. Now, as teachers of civil engineering, as architects, can we just stare at it and go? No, you cannot stare at it and go. Actually, it is, I don't want to look at the problems, I don't want to look at the history, but Indian government itself, they took more than 40 years after independence to realize that there's a problem in the housing sector. They realized 2 things. One, housing sector is a sector that actually provides maximum employment in this country. Construction sector gives a lot of potential. When you talk about employment, this is labor, employment generating kind of a activity that is happening. So the promise is there, the potential is there, but unfortunately numbers cannot be bridged because it will go beyond everybody's comprehensions. How do you face this issue? You have to have, there's no other, you have to reduce the cost of the building. How do you reduce the cost of the building? By looking at alternative. What is the alternative? And appropriate technology is the only way to bridge this gap. I'm telling you, if you want to do the housing situation in India, there is no other way but to go for appropriate materials and technology. On the other hand, there is this onslaught of negative globalization. When I was 2000, when I was passing through that junction of history, I was actually very happy because I could see the changes that have been happening 1980s, 1990s, 2000. I was very happy about it. But what is happening What is the effect that globalization is bringing? Globalization is bringing heavy urbanization. Urbanization, the pace and intensity of urbanization is something imaginable. Let me tell you that. The pace and the intensity of urbanization is unimaginably big, large. India, it's a third world country. In 1980s, 70s, we were talking about 60% rural and 40% urban areas. 2020, we are talking about 70% urbanized area and 30% rural area. I'm telling you, I may not be around at that time. By 2060, we'll be talking about probably 100% urban spaces. When I say 100% urban spaces, how does it affect the housing sector? The pressure of infrastructure. When I say infrastructure is success, in terms of water supply, in terms of waste management, in terms of housing, it's all connected with civil engineering. This is why I name it as onslaught of negative globalization. The impact is going to be terrible. The impact is going to be terrible. The poor are going to be more marginalized. Government is not going to intervene. All the supports are going. My dear friends, this is why we need appropriate methods and technologies to be mainstream. And this is the only hope forward, only hope for the practitioners of housing forward to looking for appropriate materials and technology that will lessen the burden. When I say lessen the burden, I'm talking about the cost effective. Appropriate means cost effective. Appropriate means energy efficient. Appropriate means environmentally sensitive materials and technology. So this is why we need appropriate materials and technologies. Now coming to the building part of it. What do you really mean by sustainable buildings? There is something which is very, very critical. People are using it left and right. People talk about sustainability, appropriateness, things like that. But sustainability to me is talking about local solutions. It should respond to the local climate. It should respond to the local culture. It should respond to our lifestyles. It should respond to local capabilities. And then the technology and materials come. And that is what actually makes a building sustainable. Why should I talk about local materials and local technologies? And why should I talk about mainstreaming these technologies and materials into the main template? I'll tell you, my dear friends. In 1920, when Mahatma Gandhi, the father of the nation, was talking about a new paradigm, they're talking about Swaraj that's going to happen. He was talking about strengthening the rural areas to meet the challenges of the coming days. He was actually talking about local capabilities and local technology. He said, he made a very epoch-making statement when he said, whatever buildings that you are going to make, it has to be brought from 5-kilometer radius of the proposed site. That was huge, my dear friend. That was huge. The impact was huge. Within 5-kilometer radius means you have to use local materials. Why I should people local materials all the time? COVID times, we have realized that we cannot bring anything from Tamil Nadu. We cannot bring anything from Karnataka. We have to talk about climate resilient building. What do you mean by climate resilient building? We need to respond to Kerala's climate. It can be completely different from Himachal Pradesh or Punjab or Rajasthan. We are in the tropical area. We have rainfalls. You can look at the sky and you will see that the sky is overcast. It should respond to the local climate means, it should respond to the rains, it should respond to the hot climate, it should respond to moderate climate. We don't have hot climate per se. Respond to that. It should also respond to the humidity. Kerala has a long coastal line of nearly 700 kilometers. Humidity levels, at least that part of the state, is very high. If you don't develop materials and technology that respond to the local climate, it's going to be disaster. We have a lot of material that can be used in any climate, that's for sure. But if it's on the seashore, we have to develop, we have to identify the local materials which can, withstand the onslaught of climatic vagaries. Culture and skills are very important because, again, We have been depending very heavily on the migrant laborers. I'm telling you because I work across the world. Across the world I'm working. In Africa, in many parts of Asia. My buildings are all out there. Let me say it with such pleasure, such conviction. Where else can we find a better skill resource in the world? Our masons and carpenters are the best in the world. They may not have the tools, but the skills that they have is something which is incomparable. Which means a huge repository of building materials. We have a culture which is very responsive to the sustainability part of it. When I say that, I say it with such conviction. Earlier, when we used to cut a tree, we used to ask for pardon from the mother goddesses. Why? We were talking about compensatory planning in those days. We talk about compensatory planning. So culturally, our culture always responded to climatic this thing. We had to see, when we start a building, we used to do this puja, some kind of a ritual to please the Mother Earth. That culture is being very badly diluted. That culture talked about sustainability in a very big way. I will come to the details of technology and materials later, but let me move on to the next slide. Before that, let me tell you, whatever resource that we have means availability of technologies and materials is there on the doorstep. Don't look out. Don't look to the west for answers. We have the resources. We have the material. So build with those materials, and that itself will ensure sustainability. The next big parameter is affordable. See, you can talk about sustainability in a completely different way. When I was much younger, I was connected with those days, the regional science laboratory. It's under the CSIR initiative. Now it's called interdisciplinary something, connected with sciences. They developed a beautiful brick made out of coconut husk. Coconut husk, local material, probably waste material. They made a very beautiful brick, it is very easy to lift, very easy to throw, dimensionally very stable, beautiful edges, very stable, very strong, and very easy to carry. You could carry 4 or 5 bricks in one hand. That is very good, very beautiful color, texture. An architect would cherish all those qualities of the material. Very good. But we couldn't. I tried to put it in the market. We couldn't do that. Cost was not in our favor. When I was getting local material, local bricks for walling for 3 or 4 rupees, CSIR had priced it at 12 to 13 rupees because 3 times higher than the normal brick. My dear friends, we are talking about sustainable building materials and technology. Unless it is affordable, there won't be any takers. This is how you should package the material. It should be affordable, it should be there on your doorstep, and it should be local. Let me tell you this. Local is the mantra when I talk about this. Let me also, before I go into the crux problem, let me also talk about, we have to realize this. Everything you have to, when you talk about a subject, you have to have the paradigm very clearly defined. You have to know about the climate changes that are happening. It changes the water pattern, changes the temperature, changes the energy, air, environment, and the soil. You know something, I've been telling you that I've been very active in the disaster mitigation field for the last 3 decades. Having said that, I don't know, civil engineers should know about it. 2018, first happened. But it didn't really kill many people. Yeah, it killed, isn't it? But the newspaper reported it killed people. Mind you, it was a completely new phenomenon that killed people. It was not the floods per se. It was something else that killed. In 2018, Puttumala, the beautiful verdant hill in Wayanad, it came down. In 2019, when floods happened again, another mountain came down. That is in Kozhikode district called Kavalappara. That hill also came down for one reason, not really flooding. New feelings. See, when tsunami happened in 2014 December, I was there, actually on the shore of Tamil Nadu. I saw this happening with my own eyes. I could see tsunami. Then I realized that in 1999, when I was working in Odisha, it was the same phenomenon. I didn't know. As a person, I had been working very intimately with international development organizations. In 99, it happened in Odisha. I didn't know. Because this phenomenon was completely new to me. In 2014, when it happened, when newspaper, the media people told me it's tsunami, then only I realized that in 1999 I saw the same phenomenon. A new phenomenon is happening in Kerala. Soil piping. I don't know whether you heard of soil piping. Soil piping is a devastating phenomenon that is destroying Kerala. Uttamala came down because of soil piping. Kavalappara came down because of soil piping. And how does soil piping happen? Unsustainable building activities, unsustainable mining, unsustainable soil mining, unsustainable ways of building on the mountain. All this is adding to the challenges that the climate is bringing now. Water, I don't have to qualify that. Kerala, we have 44 rivers. And all the 44 rivers are dying. All the 44 rivers in Kerala die. And the English poet is that water, water everywhere, but not a drop to drink. We are using, let me tell you this figure. I let it skip. 5 billion liters a day. Let me reiterate my statement. We are using 5 billion liters a day to flush out the dirt from our toilet. Dirty water. 5 billion liters of potable water. Water everywhere, but not a drop to drink is the Indian situation. Temperature is rising every day. We need cooler interiors. Inside the concrete monstrosities that are continuing to build, we are suffering. It is becoming kind of unbearable. Each time temperature is going up, we have to look at the rise in temperature. Air. I'm sure one of you should be able to answer this. There's a big indicator called indoor air quality. Have you heard of that? I'm sure some of you must have heard of that. Indoor air quality is extremely critical, extreme importance now, especially in COVID times. Because unless you have clean air around you, unless the indoor air quality is maintained, you are going to have very difficult time. Probably death is awaiting us. We think the atmospheric air is full of pollutants. When some sunray falls through the air, we see a lot of dust and soot floating we see a lot of particles floating in the air. My dear friend, sitting inside is more dangerous. Sitting inside an air-conditioned space is lethal. Very, very bad. Because you are harboring millions of microorganisms inside that area. It's contrived. So how do you ensure indoor air quality? Open your windows. You ensure the indoor air quality, high quality of air inside by opening your windows. It's as simple as that. We don't have to have technical answers. Open your windows, wind will rush in. If it's an opening on the other side, you will go. This kind of movement is very critical. This is how you should change. This is what I'm telling you. You need only local answers. You don't have to have big engineering interventions. Talk about technology. It's a design paradigm which can really ensure high quality of air inside. Energy, again, if I talk about energy impact on buildings, I'll probably take another session. I'll just read out some statistics which you should keep to yourself. There are two phases in building construction. One is the pre-construction phase and the post-construction phase. 32% of the total wood harvest. That means The number of trees we cut down, 100 trees, we have to use 32 wood from 32 trees for building construction. Environment is very badly being mutilated, energy is being mutilated. You know, the wood harvest, the energy usage, 32%. 32% of wood harvest, same percentage of energy consumption that's happening in India is happening in the construction sector. So unless these issues are being addressed, how can we talk about sustainability? The main threats of climate changes will have to be linked to sustainability, and that is how we go forward on that. And let me very briefly talk about the contemporary crisis, which is a very hugely disturbing. The price of the material, availability of material. You know, the prices are just going above the roof. Last 2-3 weeks, basic materials are all costing more now. 20% rise of price in terms of cement and steel. Price have gone up by 20%. We have lost the legacy of our labor, our skills. The quality and the quantity of work that are being very badly compromised. Expertise on one side, exploitation on the side. I want to dwell 1 minute on this. I don't know whether you understood when I said expertise and exploitation. Every disaster is an opportunity. When it happened in Kerala, a lot of structural experts came talking about foundation solutions. Those days, I was appointed as the chairman of a national committee, Government of India, to look at framing of, selecting disaster mitigation specifications for the construction sector. And when I went to Arattapuzha, where tsunami happened in Kerala, I saw people from Institute of Technology in Chennai looking at the soil. Government of Kerala came out with such funny foundations for these small houses. They wanted underream piles. Most of you must be knowing about underream piles. Underream piles is a highly technical intervention. It talks about a lot of steel, lots of cement, lots of aggregates. Monopoly business. Local people don't have the expertise to do this underream piles. What happened is the project, Government of Kerala brought out a project for 6 lakhs. 4.5 lakhs they spent yearly on the underream piles. Before the pile cap, underream piles, before they did the pile cap, they spent around 4.5 lakhs. Monopoly business. 1.5 lakhs. Local people don't have the expertise to do this underream piles. Even cast the roof. What happened is the project. So, every disaster project for 6. What is my answer to that? I think a very simple experiment. Yearly, actually, when you talk about foundation, we talk about bearing before the pile cap. We talk about a lot of underream piles. Bearing cap before they do pile cap is something that is hold a building together. How do you test the bearing capacity of CSAP? Look at many friends we look do this underream piles, microscopic lens. Understand that? So, each of the sand grains that is particles. What is my answer to that? It's highly crystalline, very crystalline. Simple experiment. Yearly each. When you talk about foundation, we talk about before this very fine underneath piles. Before they do what happens? Something that is hold a very sharp edges. How do you locate CSAP? Many friends will locate edges. They have very clean, sharp edges. Sea sand will never yield. I'm telling you, sea sand is one of the best strata that you can find if you want to build building. What are we doing? We are talking about single-story small buildings. Only problem was covering. What do you mean by covering? Waves will come in. When it goes back, it pulls some of the earth away. The only way is to go deeper into the soil. If you are building on a seashore, go for deep foundation. This is the kind of technologies and things like that we had been promoting. I don't think anybody in the world has done as many buildings that I've done during disaster situation. In Sri Lanka alone, I did around 95,000 houses. It still remains as a world record. So this is what I meant by expertise and exploitation. I don't want to talk about building rules. The undesirable construction practices also add to the contemporary crisis. If I get time, I'll go a little deeper into that, and obviously the land issues. Now, how do you select the technology? Let me come to the subject straight away. It has to be a climate resilient one. It has to be addressing traditional skills and looking at local capabilities. This is how I select my materials. This is how I select my materials, because I'm very sure of the parameters. Whenever I take a technology, when I take a material, I talk about climatically, it should be resilient. It should be traditionally acceptable. Brick is acceptable, laterite is acceptable, local stones are acceptable, mud is acceptable, bamboo is acceptable. Because we have a huge legacy of knowing, seeing bamboo buildings and mud buildings and things like that. So tradition is very important. And technologies and materials that can be promoted using local skills. It's another little thing that I wanted. This is how I select my technologies. I'm going to actually talk about technologies and materials together, because technologies don't exist alone in a watertight compartment unless it's linked with materials. So basic theme of my presentation is about materials and technology, sustainable materials and technology. That's what I want to tell you. This is my indicators, my parameters for selection of material. Definitely when you select a material or any technology, you need the strength and durability. That cannot be compromised, at least in Indian situation, because they're actually building these houses to remain for a generation at least. So we don't want flimsy material that can collapse if a calamity happens. We want very strong material, and we want durable material which will be weather resistant, durable, to last for a long time. There's no compromise on that. One of the critical criteria for me is the cost. It has to be cost effective. Unless I told you about the example of my experience with those beautiful bricks made out of coconut pith. Unless the technology and the material is cost effective, there's no point, because India still remains as a poor country. And if you want to build it in numbers, we need to talk about appropriate technology for whom? Appropriate technology for people who don't have houses. They make a huge percentage. It's not the people who are moneyed and for rich. For whom are we building this appropriate? It is for the common man and the poor section of society. Cost is definitely, if it's costly, let us not promote it. That's the end word. If we want to promote a technology, we have to be very clear about the cost factor. Insulation. Very, very important criterion as far as Kerala, South India is concerned. We want insulating material for walling, for everything we want insulating material, because the temperature rise. It's very increasingly difficult to stay in a concrete house. We need insulating materials. And to my pressure, let me tell you that some of the materials that we have that are locally available, they have a huge insulating property. I'll go to that a little later. And by using appropriate technologies, we can insulate the buildings. Insulation is, to me, a very important criterion. I told you about local availability and local skills. I don't want to, take more time on that. I'll just skip to the other slide. Maintenance and retrofitting is something that we don't take care, my dear friend. When you talk about appropriate technologies and materials, this is something that I want to tell you. A lot of maintainable buildings are being badly mutilated and demolished. When you are demolishing a building, actually you are demolishing a life. When I define life, I am talking about resources. The best way is to maintain buildings properly. That actually talks about a lot of resource efficiency. We don't look at it. Instead of that, we demolish buildings for very silly reasons, for beauty, for lack of conveniences and things like that. Go to a good architect who will tell you about how this building can be transformed to meet your present requirement by probably taking a wall off, putting a new window, things like that. Let me tell you that maintenance and retrofitting. Have you heard of retrofitting? Retrofitting is a word that you should mainstream in your mind. Retrofitting means we have to look at the challenges, look at the problems, look at the difficulties, look at the cracks and leaks that can happen in a building. By addressing that, you're actually retrofitting. Disaster situation, a lot of buildings which have suffered some minor cracks and damages can be rebuilt, can be renovated. Most of the material can be reused. These are very critical as far as maintenance is concerned. And when you talk about sustainable, there's a general feeling that these sustainable buildings are not disaster resistant. I'm telling you, when we mainstream a material, when we mainfresh a material, we talk about disaster resilience, we talk about climate resilience, we talk about post efficiency, we talk about eco-sensitivity, we talk about energy efficiency. The same breath. It cannot be in different compartments. So whenever we build sustainable buildings, because in the disaster situation, why I should talk only the poor people who get killed. Poor people, most of the people, casualties are from very, very poor communities. Talk about Thailand, talk about Indonesia, talk about Maldives, wherever, Sri Lanka, where these kind of devastations have killed hundreds and thousands of people. These poor people who get caught because they live on the land which is very vulnerable. Now, when we are talking about disasters, and buildings are the main cause of it. You get trapped in the building. If the building is not disaster resistant, the building will collapse on you. This is what I'm trying to tell you. By simple interventions, by very simple interventions, by very minimal engineering kind of interventions, you can make a building disaster resistant. I'll just tell you a very small example. You can tie the building at 4 or 5 levels. Plinth beam is one tie. Probably the sill level, sill level, we can have another tie. At the lintel level, third tie. And the building corners reinforcement, some kind of a reinforcement. So what happens in a disaster situation when the earth shakes, floods come? The building will resonate with the forces of nature. If it resonates, nothing will happen to the building. It will not get collapsed. But if it resists these kind of frequencies, then buildings are bound to come down. Disaster-resistant areas. You need very simple engineering solutions to make the buildings disaster resilient. What are solutions? To maximize greenery, to help, plant trees. I still believe that trees are the only answer. Build up housing literacy. That house is not about building 4 walls. It's beyond that into environment, into soil management, water management, water conservation, things like that. Upkeeping of buildings is very critical. Retrofitting is critical. There's so many spelling mistakes in this. You have to look at natural, alternative, reusable energy-saving materials and alternate technology, and use local expertise. That grade are the solutions to this particular. And I told you the world is losing options. Reuse renewable materials, mainstream them, reuse, recycle. These are the only ways to look at this. I'm just finishing one part of my presentation. Let me very quickly come to the next this thing. How this technology's material can be in all the building components. I'm talking about foundation to walling to roofing to flooring and to joinery. Post-effective technologies and materials can be used. We never talk about foundation. Post-effectiveness, no, we don't talk about that. We talk about walling. Yes, there are several options before you. Several options, validated by Central Building Research Institute. They are all there. You know about certain options. But for foundation, roofing, we are very, very fluid. If you want to make your building sustainable, You have to look at all these elements, 5 elements. That include foundation, walling, roofing, flooring, and joinery. The time is very short. I may not go at length, but I will just mainframe some of the technology that we are trying to mainstream. Ratra board, for instance, is actually a cavity wall. A cavity wall. We sometimes call it rat trap board because the rat gets trapped in this, it will not be able to escape. So to make it easy to remember, we call it rat trap board, but it's actually a cavity wall. 9 inches wall, a cavity wall. What happens? The number of bricks come down. You get fair face on both sides. No plastering neither. When you avoid plastering, what happens? Sand comes down, the quantity of cement that is labor comes down. And what happens as an after effect? Insulation. The space in between actually insulates. The air column in between insulates. People think that this is, this is not strong enough. We went to Central Building Research Institute. We went to CERT, Structural Engineering Research Institute at Chennai, for validation of this technology. How do you measure the strength of bricks? The strength of bricks is the compressive strength of the material. The compressive strength of normal, ordinary thing is very high. Very high. We always multiply it with a factor of safety, and the results are quite acceptable. Ordinary country-born bricks are very, very strong in this thing. These bricks, I mean, you'll be surprised to know this. This is stronger than an English-born or Flemish-born kind of masonry. Because you are putting the bricks on edge. I'm telling you, when you really look at it, and I'll put it another way. You take a brick, a stronger lot among you, the male members. Probably if you are trained in karate, you put it on a support, with one chop, probably you'll be able to break a brick. But if you put the brick on edge and try to chop it, your palm will get broken, not the brick. Very simple technologies and very simple engineering. And aesthetics is very beautiful because you get both the faces. Normally when you do a brick masonry 9 inches, you get only one face fair. Other face looks terra, completely out of this thing. So here what happens is that you get both the faces, no plastic thing, more strength, better, and you get insulation in between, and it can be done by local skills. That's why this is how you should promote a technology. SLAB roof. Cost effective. Why is cost effective? I'll tell you a formula. You can criticize me for that. What is the formula that you use for measuring the quantity of steel in an ordinary quantity situation? To me, 100 square feet of concrete in RCC slab will require roughly around 80 to 90 to 100 kilos of steel reinforcement. Am I right? I'm sure you will say it right. 80 to 90 to 100, probably to 110. The spans are more. This is the amount of steel that is required. Now, when you're talking about filler slab, I'm talking about 35 to 40 kilograms per 100 square feet of area. Are you shocked? I'm sure you're shocked. How do I reduce the quantity of reinforcement inside the slab? Is something that is quite interesting. I should actually tell you that. How do you calculate the strength of RCC slabs? What are the criteria of this dead load? Many of you may not even know the weight of concrete. 1 meter cube of concrete, that is 1 meter into 1 meter into 1 meter. 1 meter cube concrete weighs around 2,400 kilos, my dear friends. 2.5 tons, my dear friends. 1 meter cubed of concrete weighs 2.5 tons. You can imagine the self-weight of the slab. Self-weight of the slab is very, very critical. That is the most important criteria when you design RCC slab. The self-weight comes down by more than 50%. Now let me come to the dynamics of RCC slab. There's a tension zone and there's a compression zone. I'm not a civil engineer, but let me tell you, steel takes the tension and concrete takes the compression. When I say about RCC slabs, there's an imaginary neutral axis that passes through the center. Below the neutral axis is the steel. Above the neutral axis is compression, and that is concrete. Below the neutral axis is tension. But how can the reinforcement stand alone? You need some kind of covering. That is why we put concrete around the steel. Why do you need to put concrete around the steel? If it acts with atmospheric air, rust can, iron oxides can deposit, it will eventually affect the strength of the material. To insulate the material completely from these kind of atmospheric vagaries, chemical reactions, we pack it using concrete. Concrete doesn't have any other function in the lower side of the concrete. So we take the concrete, the weight of the concrete comes down, and we have two waste tiles, rejected tiles. It's a filler material. It need not be a rejected tile. It can be thermocol sheets. It can be any damn waste material. It can be trash. You get it at a piece, and it's very easy because once you take the shuttering out, it will look good. You can see the picture on there. It looks good. So these kind of materials, I was talking about rat mount as a walling option, a filler slab roof. You need lesser reinforcement. You need lesser quantity of cement and sand. And to me, it insulates. There are no, we put two tiles, one on top of the other, where we don't need concrete. There's a space, the profile of mangrove tiles, and it is slightly corrugated. And the profile actually shows that there's a small air gap in between. That air gap actually insulates, very important, it insulates. And we have tested the load, this thing, equally strong as a very conventional RCC slab. And you don't have to bring people from outside to do this filler slab. Our people know about it. The only thing is that you need to look at the spans, you need to, for everything, if you want to mainstream a technology material, you need to have an engineering skill, engineering knowledge of the material, about the technology. That has to be followed. No shortcuts. If you follow the quality monitoring mechanism, then this technology actually saves a lot of money. And on the other hand, it's insulating and a very local solution. People had been ridiculing me for using terracotta material. This particular seminar is actually based out of Chelakara. Where else in the world can we get such beautiful building material like terracotta other than Thrissur? There is a hub of these kind of things. I don't want to go at length because time is getting very, very limited. Let me tell you, this is Kerala's contribution to the building vocabulary. When I say Kerala's contribution to the building vocabulary, I'm talking about, say, the only healthy flooring material that man has ever kind of explored. It's not only cool, it's healthy. It's soft under the foot, made out of mud. It talks about therapeutic properties. I'll give you a very small example. If you lie on a marble floor, a granite floor, you go to sleep on a marble floor, you won't be able to get up the next morning. You'll have a lot of muscle cramps. Try sleeping on this floor. Next day, you will wake up refreshed, full of energy. That is why I'm telling you, this is a very simple example which you could learn. Low cost, energy efficient, eco-sensitive, local material, and local can be done by local skills. And that is why I talk about this sustainable material like that. When I started mainstreaming rubber property 30 years back, people used to take it only for packaging these things and things like that. For waste, boxes they used to, after taking the latex of the tree, 25 years, and you have to slaughter it. That's the word that we use, slaughter the wood. Slaughtered wood would get carried away to some factory where they make waste boxes, temporary packaging and things like that. It's people like us who mainstream rubber wood in the main building vocabulary by looking at the properties of the wood. I don't want to go at length because it needs a process. We have to take the moisture out, we have to make it insect proof. But once you do this process, it becomes less costly. Wood is an extremely costly material now. It's eco-friendly because anyway, you cut this tree after 30 years. So one of the most eco-sensitive solutions that we have, otherwise it goes waste. They're reusing probably a waste material. And if you can attain the same strength, in fact, in places like Malaysia, it's called green teak. Places like Malaysia, it's called green teak. To the next slide. The last section of my presentation, I'm just going to put a very provocative kind of material and technology to you. Because I'm telling you, I've been building with earth-based material for the last 15 years. I've been concentrating. I've stopped using bricks, for instance, as a mainstream building material. Instead, I'm going for stabilized mud blocks and mud constructions. Last 15 years. Because I realized my mistakes in my own life, my professional practice. I realized that, burn bricks is one of the most unsustainable materials that we can use. Unsustainable in terms of energy sensitivity and eco-sensitivity. So I realized it much later. You learn through your mistakes, but that is when I started turning to earth as a very basic building material. I'll quickly run through these. Why earth? Available everywhere. There, in your backyard. You don't have to search for that. And cost, it's a no-cost material because it's there with you. There in the site. It's a no-cost material. It's not a low-cost material. It's a no-cost material. You don't have to have foreign migrant skills to teach us about how to make mud building. We have the best skills available. Local skills that we get anywhere in Kerala. They're very good, capable, and they know these skills to make these mud houses. Aesthetic, I'll show you how aesthetic is that at the later this thing. Very beautiful, intoxicating to me. Very, very beautiful. And aesthetic, I don't think there's a material that can surpass the usage of earth. No energy because it doesn't go through a process. If you go through a process, that's when I started moving away from burn bricks. Burning of bricks is a process. You have to cut coconut trees, you have to burn it. Burning is not a good process. It's not a sensitive process. It's not an eco-sensitive process. And this doesn't need any kind of burning. No energy material, most eco-friendly because you're not exploiting a resource space. You're using your own earth. And if it can get enough strength and durability, nothing like that. I'm telling you that it got strength because I used it as a load-bearing building material, not within the frames. As a load-bearing material, the largest earth building in the world. I'll show you a picture of that. It was built by me in Bangladesh a few decades back. I'm telling you, mud walls can be load-bearing, 3 floors, 4 floors, 5 floors. It can be load-bearing walls. Nothing like, if you go to Google, search, you'll find several example testimonials to the multi-storied buildings in Yemen, in Sana'a, for instance, Morocco, many places, old Arab buildings, they're all built of earth. And one of the images of those buildings will give you a lot of confidence. And how do you test the material? Very, very interesting. I taste it. I don't go to the field, in a tribal village or in interior Odisha. There's no way you can take your mud to a laboratory and test it. I don't have to tell you, you're all teachers, you have much better equipped than myself in academic terms or laboratory terms. But some of the things that we do is to taste it. Taste. When I say taste, if it grinds between the teeth, it means a lot of sand in that. One of the ingredients of soil. You talk about gravel, you talk about sand, you talk about silt, and you talk about clay. These are the four basic verticals of Mother Earth. Of gravel, you cannot taste it because it will hurt you. Sand, it will grind it between teeth. Yes, there's a lot of sand in that. It will melt like chocolate. It means a lot of clay in that. If you feel like putting the maavu feel like having duff. That means a lot of silt in that. That's how we do some field tests to ascertain the composition of Earth, and by looking at there are a lot of tests. I don't want to, but these are some of the tests. Look at the color. If it's musty color, blackish, it means a lot of organic. This thing is there. You can smell, and if you get a musty smell, we don't take it because organic impurities is a habitat of insects. Termites and things like that. Became very, very bad. And I don't want to go into this thing because time is getting very, very limited. 12:10 already. These are some of these things that we do, like everything else. And where can we use mud? Yes, you can use it in foundation. You can use it in walling. You can use it in roofing, and use it in rendering. When I say this, I say it with such conviction. Some of you, after you finish this presentation, you can go to the net and look at my own building, my own residential building. My name is Shankar, and you can Google on your YouTube, and you will see my own building. This is the first building probably in Kerala. They have used mud as a roofing material. Roofing material without reinforcement, without any cement over that. You see, floods came to my building in 2018, and it still stands. Extreme testimony to technology is when water came into my building, and people came to see whether the building is still there.
Good grammar and spelling are important, but if you want to write essays that inspire,
they were looking at all these. I'm telling you, mud can be used as beautiful, strong, durable foundation. Mud can be different walling for roofing, etc. And I had to quickly go through this because otherwise I'll leave it half finished. Cob is one way of doing it. You put it. You take the mud, take it out as a football, and make it round footballs, throw it in one on top of the other. It's a very rustic technique that has been used for centuries together. This particular technology is called Cob construction. Adobe construction is something that we are all familiar with. We call it Pachakatta in Malayalam. We go to the village side, you see hand-dried bricks. This is actually Adobe's hand-dried bricks. You take mud in a small mold, using sunlight, you dry it, and then use it for small buildings. It cannot be used for multi-story buildings. Cob can be used for multi-story buildings, but not Adobe. Adobe can be used at most for 1.5 story high buildings. Rammed earth is, you put shuttering on both sides, put earth in, and then ram it. Very extensively used in Europe. Very extensively used in Europe, in Australia, Europe, United States of America, where you find these kind of materials, these kind of rammed earth construction, very popular, very strong, but not very acceptable to Kerala because we need shuttering materials. Shuttering is costly. You need to bring a carpenter, and you need to pay rent for shuttering materials. But the basic materials is completely free. So nothing like that. And what happens when you take the shuttering off, you get beautiful finishes. Very beautiful solution for walling. Wetland of the picture that you heard, that is again something that you see as a common sight, this thing in Assam, in Northeast Asia, in Assam, in Northeast India, and eastern part of the world, Laos, Cambodia, Indonesia, and things like that, Thailand, Malaysia, you get this wetland dog. One of the great advantages of wetland dog is it's earthquake resistant. In earthquake-prone areas, this is very good because you will not die. The walls will wobble, probably mud will come out. But the wattle, this is the main structure, bamboo, that will not come out. And you can put back the earth by daubing. Daubing is actually smearing earth over a framework. That is called daubing. Job is that. And stabilized earth block which I use. This is how Kobe is being constructed. This is how Adobe is being done. This is how you do the rammed earth, and this is how you do the wetland block. And I'm actually promoting stabilized mud blocks. I'm the person, let me tell you, that single-handedly actually started promoting, mainstreaming this material, and it has become a kind of cottage industry across Kerala. In most of the areas, you get hundreds of factories now producing these kind of stabilized mud blocks. Huge technology, this thing forward. I think this is the material for the future because it's less costly, very interesting self-help method. You can actually make some of it in your site via a small machine. Good resistance to weather, very labor intensive, which is needed for Indian economy, and very stable and very strong. Why you use stabilize? You need to bind the particles of soil, you need to waterproof, and all these things. Where do you get the mud from? If you have a small little plot, I'm telling you 6 cents of land, and 0.266 meters, 26 centimeter, you get all the mud required to build probably a 300 to 350 square feet of house. Only less than a foot of soil will help you to build that. And obviously, when you talk about technology, termites, this thing, damned is an issue. Central Building Research Institute has brought down some specifications. It's called non-erodible mud plaster to prevent dampness. And for the termites, you have to go out. The richest lime deposit in the world is in Kerala. And no other agent like lime. If you mix lime with mud, you have a resistant wall. Local technology. This is the picture of my office, and you see the mud buildings are, I'm actually sitting in my office. I will show my face after I complete this presentation. People think that mud buildings, the shoddy, low cost, not aesthetic. This is a picture that was taken 15 years back. 15 years back. Strong building, 4-story building. These are some of the, I know, by looking at the picture itself, old building. And this particular building, I don't want to, time is limited. The first earth building that has come out in Kerala, using for an IAS officer. Then she was an IAS officer. Huge story behind this EMS Academy. EMS Academy, library block made out of that, yeah. And a few resorts, all made out of earth, And this is what I wanted to show you now. Why I wanted to tell you about appropriate, this is the only way forward, my dear friend. You are losing options. This is the only way forward. I will stop at this particular point because the time is already past 12:15. At the time I wanted to leave, I will still remain in this platform for a few minutes, and I will come back. Can you help me to put me back to the screen? I'll just take a minute to come back to the screen. Kindly hold on till then.
Okay, sir.
Yeah, can you see me now? Yeah, I'm open to questions. If we can put, I'll be happy if we can put it in the chat box. Is there, no? Chat box? Chat box is there, no? Yeah, yeah, Anita, if they can put the questions in the chat box, I'll be able to answer that. Few questions, 2-3 questions, I'll answer that quickly. My dear participants, you should ask me questions because otherwise it will be completely meaningless. Either it means that you have not heard me, or it means that it has gone beyond your interest. So one of these will happen if you don't ask me questions. I will probably leave sad because I spent an hour talking to you. So please, to save my credibility, ask me some questions, please. Yeah. Yeah, I mean, I'm telling you, uh, uh, I'll very briefly answer your question. You saw the parameters, indicators. The spelling, I think, is. Are you talking about neem? The question? No, I'm not talking about Anita. I mean, I'll answer that question later. But somebody else put something on the chat box. What is the use of neem? Or is it NEM? That is something I'll come back to.
NEM.
Latish,
yeah, NEM, non-erodible mud mortar.
Okay. I'm not very familiar with abbreviations. Sorry. I mean, I'll come back to that later. I'll come back to that later. Can you mute yourself? Because, yeah, thank you. And Anita, your first question is about the comparison. You saw the set of parameters that are used for selecting a material and a technology. It talks about durability, strength, it talks about insulation, it talks about eco-sensitivity, it talks about energy efficiency, it talks about local availability, it talks about local capabilities, and a few parameters like that. I select mud earth because it meets all the parameters: strength, durability, insulation, local availability, built with local capabilities, and resistance to vagaries. I'm very sure about that, and that's why I use mud earth above the other material. I'll just qualify my statement a little bit further. This is a very abstract, overarching response, but to qualify that, I use mud as a walling material. What is the criterion for the strength of walling? It's your compressive strength. Compressive strength of the walling material. What is the compressive strength of normal adobe bricks? Sun-dried bricks? It has got a compressive strength of probably 10 kilos per centimeter square. To you civil engineers, this is unacceptable. But to me, as an architect who has been building, I myself is a mason. To me, 10 kilogram per centimeter square is acceptable. Acceptable to me. Not to you because you go by PWD manuals. But you all will agree that a conventional brick, burnt brick, has a compressive strength of nearly 20 to 25 kilograms per centimeter square. Very good. It can be used as a load-bearing material. Stabilized mud blocks that are used for my buildings, we are talking about 40 kilograms per centimeter square. It's a very high percentage of strength. So this is my brief response to Anita, who asked me first question, why I choose mud above the others. The second question, people were talking about non-erodible. Yatish sir, Sridhar Padikar, they have been talking about non-erodible mud plaster. Non-erodible mud plaster is nothing but plaster with a bit of cement in that and some adhesive. What is that adhesive? Why do you need to stabilize the plastering material? Non-erodible mud plaster is a technique being developed by Central Building Research Institute. You can see it in the website. You Google non-erodible mud plaster, it will come out. Mud has got two pronounced enemies. I showed you that. One of the main enemies is the dampness, lashing rains. Mud can, if you have mud unprotected, mud untreated mud, it can melt like chocolate. Your strength of the wall can. That is why we give a coating over that. That is what is called non-erodible mud plaster. We have a bit of bitumen, tar cutting. You know what bitumen is. We add a bit of bitumen. We actually add a bit of turpentine. We use some kind of stabilizers called cut straw because mud has got a property to shrink and to expand. To avoid that, like we eat fibers for our dietary requirements, we need fibers to actually enhance the property of the material. So that is why we use a non-erodible mud plaster. You get the rest of the details when you Google CBRI website. Third thing is that you are talking about the roofing of mud house. Roofing, I mean, any slab can be, conventional slab can be put, my kind of filler slab can be put, RCC options are all possible on a mud house. But I'm talking about a completely different technology. It's a vault construction. Unfortunately, the time is very limited. You put actually bricks like a wall, like an arch. You put layers of bricks like an arch, it actually stands. And that, when you stabilize a material, actually waterproofing also happens. So that is how I use my vaulted roof, vaulted mud roof, to have a roof like that. And it cannot be told on a cyber platform. I will actually Sanjit, you can talk to me about this. But before you talk to me, kindly see some of the images of the vaulted roofs that I have. I told you, it's there on the net on YouTube, my own house. You look at it, and that will give an idea about what I'm talking about. Then I'll be happy to join. I will also leave my email ID. You can respond to me on that, on the roofing of the mud house. Termite problems. You add Palani Swami. Termite, the best thing is to add lime to that. Lime is a very strong anti-termite substance. This is our mother's knowledge, indigenous knowledge resource that we have. And you make it. You also make it termite proof by some design solutions, but time is well limited. I don't want to go into that. I'll again respond to that. Very clearly respond to that particular question. There are 101 ways to make mud resistant to this thing, even by using some design details. The question that has come from Hima is about, no, that is the feedback. Yes, my house is Anita, my house is Siddharth. You can look at it. And I think I'll have to wind it now. It's 12:23.